Hello, scholars, and welcome to this video where we'll be working on a few bond valuation practice problems. Let's get started with Buffett's statement here. There are only two variables you have to plug in to value any financial asset. That's simply the stream of cash in and out between now and Judgment Day, discounted at the proper rate of interest. So the stream of cash in for us, for a bondholder, is a coupon payment and face value. The price out is the cash flow out. The judgment date is the maturity of the bond or the term remaining. The discount rate for bond valuation is the yield to maturity. Don't get that confused with the coupon rate. All right, let's get started and price this annual coupon bond. CGJ Bicycles Incorporated is currently selling bonds with an annual coupon of 10%. The yield to maturity for these bonds is 8. They will mature in 30 years. What should be the current market price of each bond if they each have a face value of 1,000? So let's get started. Your coupon payment is an equation, and that's equal to the coupon rate times the face value divided by the number of payments in a year. So the payments in a year are going to be 1 for this one because it's an annual bond. So your coupon rate is 10%. So we'll do 0.10, 10% of 1,000 face value divided by 1. That is just going to get you 100. The yield to maturity, that's your discount rate for bond valuation, is 8%. So your IY is just 8. These are annual bonds, so there's no need to divide that by 2. They mature in 30 years, so your N is 30 periods until maturity. What's the current market price if they each have a face value of 1,000? So your face value is the future value that you receive at the end, and that's 1,000. So now all we need to do is compute for the present value. So we type in 100 for payment, 8 for your yield to maturity or your IY per period, 30 periods, in this case years, 1,000 face value, and then we compute for our present value, and that's $1,225.16. That is a premium bond, and that should check out because the market wants to earn 8%. This company's paying more, so this bond will have actually an embedded loss in it if the yield doesn't change. Find the yield to maturity of an annual coupon bond. So now we're going to find the yield. The Chauncey Corporation currently has a bond outstanding with a coupon rate of 6% in annual payments. The bond is selling for $1,222. The bond matures in 20 years, has a par value of 1,000. What is the yield to maturity of these bonds? So first, I'm going to note that the price of this bond is $1,222. You need to make sure that has a negative sign in front of it. That's the amount you need to pay today with the expectation of receiving a positive coupon payment and a positive face value. So make sure that has a negative sign in front of it. Your face value here is 1,000. It's also called par value. This is not PV present value. That's par value. That's the amount you receive at maturity. So that is a positive amount, and the payment is also a positive amount. So the coupon rate is 6%. So again, that's coupon rate times face value. It's divided by 1 payment in a year because this is an annual bond. It would be divided by 2 if it were a semi-annual bond. So that's 6% of 1,000 over 1 is still just going to be 60. N is 20 years. And so we have all of the variables, and let's just plug them in. $1,222. Make sure that's an outflow, cash outflow. That's what you're paying for this bond. So that's your PV. Positive 1,000 future value for face value, par, as it's called in this question. 60 for your payment, coupon payment. 20 for your N. And then we're going to compute for the yield to maturity, and we get the yield to maturity. Your calculator is going to give you this in a percentage form. So that's 4.32% yield to maturity. Find the years to maturity of an annual coupon bond. TS, Taylor Swift Industries, has a 10% coupon bond outstanding with a current market price of $1,200. Yield to maturity is 8%. Face value is 1,000. Interest is paid annually. That's key. How many years until these bond matures? So Let's fill out what we know. The current market price, again, that's an outflow of 1,200. So put the negative sign in front of it. The yield to maturity, that's your IY per period. That's 8. Face value is 1,000. How many years until this bond matures? We need the coupon payment still, which is your coupon rate times your face value divided by the payments in a year, which is 1 in our case. So that's just 10% of 1,000 divided by 1 will get you 100. So again, we're just going to fill out all 5 of these buttons, this row of N, IY, PV, payment, and FE, and solve for the missing one. So 1,200 outflow, this plus minus sign at the very bottom, PV, 8 IY, 1,000 face, 100 coupon PMT payment, and then we're going to compute for N, how many years until these mature. That's about 21 years, so 2091 years. This looks like our last annual coupon bond. You are analyzing a 20-year 1,000 par value bond, which has a yield to maturity of 15.15% from the Tay Company. If the bond is quoted at 91.52% of face value, what must be the coupon rate for this annual pay bond? So N is 20. Face value is the same thing as par value. That's your future value in this case. Don't get confused that it says PV par value. It's the face value. Has a yield to maturity. That's your I over Y of 15.15. It's entered as a percentage just like that. The bond is quoted at 91.52% of face value. So for present value, you need to specify that this is negative 0.9152 times 1,000. That's an interest rate that we're using in a formula. So we need to move that decimal 2 places. So then we'll solve for the coupon payment, and that's just step 1. So 20 is N, 1,000 is your face value, 15.15 is your yield, and then spot 9152 times 1,000 equals, make sure that's a cash outflow, so press that plus minus button at the bottom for PV, and then compute for payment. Your payment is $137.84 per year, so we need to plug that into this coupon payment equation. Remember, payment is equal to coupon rate times face value over payments in a year, payments per year. So for us, the coupon payment is equal to the coupon rate times face value over 1. And the coupon payment here, I'm just going to fill out, is the 137.84. So cross multiply that 1 or it'll just drop off. Face value is 1,000. So all we have is your coupon rate. If we rearrange, cross multiply both sides by 1, then divide both sides by 1,000, you'll see that the coupon rate will come out to $137.84 over 1,000. So just divide this answer by 1,000. And you'll get that as a percentage. So your coupon rate in this case is 13.78%. That's a 2-step question. Now we're moving on to semi-annual bonds. Taylor & Taylor Incorporated offers a bond with a coupon of 6% semi-annual payments, and this is crucial, circle that word, and a yield to maturity of 6.91%. The bonds mature in 12 years. What is the market price of a 1,000 face value bond? So in this case, with semi-annual bonds, you need to be careful with the timing of cash flows, the risk associated with it, and the magnitude. So on those three, I'm going to write those down. Timing, IY risk or yield, and the payment magnitude of frequency. So these 3 need to be measured consistently on a semi-annual basis. So if the bonds mature in 12 years, that's 12 years times 2 payments in a year for a semi-annual bond. That means it pays every 6 months. That's 24 periods. your yield to maturity needs to be valued at a yield to maturity per period, and it's convention to quote yield as an annual percentage rate. So if that's a rate per year divided by 2 6-month periods in a year would get you to a rate per 6-month period. Your coupon payment is equal to the coupon rate times face value divided by 2, because this is 2 payments in a year now. So here your coupon rate is 6% of 1,000 divided by 2 for 30 per period. Again, since this is semi-annual, these 3 things need to be consistently measured. If you miss one of those, you're potentially going to get the question wrong. Face value, future value is 1,000. So all we need to do now is compute for price. So 24 end periods, 6.91 over 2 equals your IY per period. 30 equals your payment. 1,000 equals your face value, and then you compute for your present value. And that is a discount bond for $926.59. Next question. The Taylor Swift Company has a bond outstanding that makes semi-annual payments with a coupon rate of 7%. The bond sells for $992.60 and matures in 18 years. The par value is $1,000. What is the yield to maturity of the bond? So again, this is a semi-annual bond, so circle that. That's a crucial detail that's going to trip up a lot of students. N is 18 times 2 periods. Timing, I like to do these first. Risk or yield to maturity here. What is the yield? When we solve this, it's going to come out as a rate per period. Now, we need to get this into a rate per year. So if it's a rate per period and there's 2 periods in a year, we actually need to multiply that answer by 2 periods per year, because there's 2 6-month periods in a year. That's what semi-annual is. So that will come out to yield to maturity as an annual percentage rate, as an APR. So I'm not going to skip that step. I'm actually going to write it down first before I keep going. And then the payment, that's equal to your coupon rate times your face value over 2, because it's a semi-annual bond. The coupon rate is 7% of 1,000 divided by 2 will get you to a coupon payment of 35 per period. So 3 things need to be consistent. N, IY, and PMT all need to be adjusted for the semi-annual effect. So it looks like we've done all 3 of those, and all we need now is face value. So par value is the same thing as face value. That's 1,000. So all we need to do is fill out these missing, fill out the ones we know, and then compute for the yield. So 36 is N, 35 is your coupon payment, 1,000 is your face value. The bonds sell for, that's your present value. That's currently what they're being valued at the market. That's a negative 992.60. Make sure that has that outflow sign on it. And then all we need to do is compute for the IY and then multiply that answer by 2. See how easy that would be to select a distracting choice? That's your yield per 6-month period. Since there's 2 6-month periods in a year for the semi-annual bond, we multiply that by 2. So go times 2. And you get 707%. Find the years to maturity of a semi-annual bond. TS Industries has a 15% coupon bond outstanding with a current market price of $12.1164. The yield to maturity is 11.78%. Face value is 1,000. Interest is paid semi-annually. How many years is it until these bonds mature? So let's take a look. Coupon payment is your coupon rate times face value over the payments in a year. That's 2 for semi-annual bonds. It's 1 if it were annual. This is a 15% coupon bond, so I'll put spot 15 for 15%. I have to move the decimal in this case because I'm using a percentage in a formula. divided by 2. Current market price is my PV. That's an outflow again of 1,211.62. Now this payment is going to come out as a payment per period. We also need to make sure to treat years carefully. The rate, the yield to maturity per period is going to be 11.78. That's an annual percentage rate. So when we divide it by 2, it's a rate per period. And then we have to be careful with time. So future value here is 1,000. That's your face or your par. So when we compute for n, that's going to come out as some number of periods. So do we multiply or do we divide that by 2? Well, in this case, we need to divide it by 2 because there are more 6 months periods in a year than there are years in a year. So we have to divide that factor by 2 periods per year. That can trip up a lot of students. So we just take 15% of 1,000 divided by 2 is your coupon payment, 1211.62 negative. Think of that as a cash outflow with the expectation of receiving a positive future value of 1,000 and the positive coupon payment of 75, and then the 1178 over 2 equals your yield per period, and then you compute for n. This is going to come out as 26, so if that is a multiple choice exam, be careful that you don't select that. That's the number of 6-month periods. So if there's 26 6-month periods or semi-annual periods, you divide by 2 to get that into number of years. So go divide it by 2. That's 13 years. And that's what the question asked for, is how many years until these bonds mature, not how many periods until they mature. Okay, we have another semi-annual coupon bond here. You're analyzing a 29-year 5,000 par value bond, which has a yield to maturity of 7.89% from the Glam Company. If the bond is quoted at 108.88% of face value, what must be the coupon rate for the semi-annual pay bond? So if it's semi-annual pay, we have to be careful with the 3 things of timing, risk, and frequency of the magnitude there, face value, and present value. So time is 29 times 2 periods. Our rate, our IY, our discount rate for bond valuation is 789 over 2. That's a rate per period. The coupon payment is what we're solving for. So we're going to need that. That's an amount per period. That would be step 1, solving for this variable. And face value is 5,000. Price is 108%, so we have to move the decimal 2 places. So that would be an outflow of 1.0888. So again, we're just taking 108.88%. If that's a percent, to move this into decimal form, we need to move that decimal 2 places, which would be 10888 times face value of 5,000. So let's take 29 times 2 for 58 n periods. 7.89 over 2 equals the IY per period. 5,000 is your face value. And then 1.0888, 3/8 there, times 5,000 equals, it's an outflow. You may get an error if you do this incorrectly. That's your PV, and then you compute for coupon payment. Now we know the coupon payment per period is $216.84. We need to use this equation now, that the coupon payment is equal to the coupon rate, I'll put CR, times the face value divided by 2 because it's a semi-annual bond. So the coupon payment of $216.84 is equal to your coupon rate times face value of 5,000 divided by 2. So all we need to do is multiply both sides here by 2, 216.84 times 2. And then we need to divide both sides then by 5,000. And you'll get to your coupon rate. So times 2, that's the annual amount now, divided by 5,000 of face value. That gets you a percentage. So if you want, you can multiply that by 100 to get to this in percent. The coupon rate is 867%. Just be careful on that one. Again, with semi-annual bonds, there's 3 adjustment factors you need to consider: the N, the IY, and then the coupon payment, which we picked up here by multiplying that by 2. And again, this coupon rate is specified as an annual percentage rate. When we calculated the coupon payment, that was a payment per period. Over here, when we multiply it by 2, that turns the rate into a semi-annual basis now. Find the current yield of a bond. So the current yield is the annual coupon divided by the bond price. So I'm going to write that out. Current yield is the annual coupon. Even if it were a semi-annual bond, it's the total cash flow you get in a year over the bond's price. So we have a semi-annual coupon payment here of 28, but we need the annual amount. So that's 28 times 2 divided by the bond's price of 978.42. Just be careful to answer the question that's asked. This is not asking for the yield to maturity, but rather it's asking for the current yield, which is the annual amount of the coupon divided by the price. So all you do is take 28 times 2 for your numerator over 978.42 is a percent of 5.72%. So you can convert that to percentage form by multiplying by 100. Find how many bonds to issue. So Seabiscuit Industries needs to raise $24.59 million to fund a new project. The company will sell bonds that have a coupon rate of 19% paid semi-annually and that mature in 16 years. The bonds will be sold at an initial yield to maturity of 21.25% and have par value of $2,000. How many bonds must be sold to raise the necessary funds? So step 1 of this is to value the bonds, value each bond, value the bond. So we know face value, par value is 2,000. It's paid semi-annual, so I need to be careful on timing, risk, and magnitude here, frequency payment. So time is 16 years, so we just take 16 times 2 for number of periods. We take our yield. Yield to maturity is 21.25% over 2, because now it's quoted as an annual percentage rate, and we need to convert it into a rate per period. Your coupon payment is your coupon rate times your face value over 2, because it's a semi-annual bond. So the coupon rate is 0.19. Again, I moved that decimal 2 places for the percentage. Face value is 2,000, not 1,000, over 2 for 190. And that's an amount per period. So again, with a semi-annual bond, you need to be consistent on 3 things. So if a question says semi-annual, be careful of the timing, the rate, and the frequency of magnitude. So all we need to do is find the bond price. So we're computing for present value. So 2,000 is your future value. 16 times 2 is your N. 21.25 over 2 is your IY. You could do 0.19 times 2,000 equals over 2. And you see you get 190. Those 2 drops off. Those 2 simplify for your coupon payment, and then you compute for your present value. The value of each bond is $1,796.60. That's an amount per bond. And then step 2 of this question is to raise the necessary funds. So you could think of this in terms of units. The amount raised, the dollar amount raised, is equal to the number of bonds issued, number of bonds times the price per each bond. So then if this is number of bonds, then these units will drop off. So all you need to do is set these two terms equal to the 2459 million. So 24,590,000 equals the number of bonds times the price per bond we just found, which was 1796.60. So your number of bonds, the quantity that is the 24,590,000 over, and I'll put the units on here so you can see the dollar sign drop off, 1796.60 per bond. So you divide by this, the dollar signs will drop off and the denominator's denominator becomes the numerator. So your number of bonds is just the amount raised divided by the price per bond. So take this number, you could just invert it and then multiply by 24,590,000. That's your number of bonds. Just be careful. It's 13,687. You have to round up for that nearest bond. Thanks so much for joining me. This has been a great video to share with you.